Hello, everyone. Is everyone able to hear me? Okay, that's great. Okay. So, a little about myself. So, I'm gonna be your TA for this tutorial. This is the tutorial number 2. So, we have 2 tutorials. So, this is the second tutorial, and then there is another tutorial. That's tutorial number 3 that actually runs in parallel with this tutorial. So, if anyone wants to join the other tutorial, they may. There is no specific tutorial for someone because this is an online course. So you can either join this tutorial or you can either join the other tutorial. So if you have any questions, you can either ask on here or chat, or you can email me. So just for everyone to know, I am just leaving my email in the chat. So this is my email address. If anyone has question, they can ask me on over here, or they can ask me over chat. Okay. So this tutorial will be divided into 2 parts. So the first part, we will be doing some questions from exercise 1.1 and some questions from exercise 1.2. And then we will have a short break in between so that everyone can catch up. Okay. So someone is asking if the recording will be on Moodle. Yes, it will be on Moodle. So we will be doing some questions, and we will be answering those questions as well. So those answers will also be on Moodle, or if they are not, then you can ask me to email you. Okay, so some answer on which exercise are chosen to be solved during the tutorial. So we have some certain set of rules according to which we decide like who is solving which exercise question. So both the tutorials are solving different exercise question. So the even number questions will be solved by the students, and the odd number questions will be solved by the TAs. Okay, so let's do some exercises.
Hello.
Yes.
Yeah, will you be able to share your screen? Will you be doing the questions online that we can see, or will you be doing it just like by speaking up?
No, actually, I will be sharing my screen. Just waiting for some people. They're in line to be in the group chat.
Oh, okay.
Okay, so let's start. Let me share my screen. And okay, is everyone able to see the screen?
Yes.
Okay, that's right. So let's start with the first question. So here we have a question. Which of these sentences are propositions? What are the truth values of those propositions? So first of all, if you have a chance to go through the slide. So a proposition is something that is either true or false. So let's do the A part. So if I say the Boston is the capital of Massachusetts, so this statement is either true or false, right? So there is no in between value. It cannot be either true or false. It has to be either true or false. So we say that this statement is actually a proposition. Now, same thing for the B part. If we say that Miami is the capital of Florida, so this is either true or false. So let me just write the answers for you. So A is true. B is also true because it's either true or false. Now C statement. We said 2 plus 3 equals to 5. So we know that this is a true statement. So therefore it is a proposition. It cannot be either false or true. It has to be one value, either true or false. In this case, it's true. And the same thing for the D statement, because it has to be either false or true. But in this case, it's false because we know 5 plus 7 is not equal to 10. So this is false statement, but this is a proposition because it's either true or false. Now, once we come back to this, so this part E, here we have a variable, it's called x. So x plus 2 equals to 11. Now this statement over here, it can either be true or false depending on the value of x. So such a statement in which there is no certainty, so we call this a non-propositional statement. So therefore this is not a proposition.
Sir,
Yes.
wouldn't B be false? Because Miami would not be a capital of Florida.
That's right, but they're asking which of these sentences are propositions. So Miami is not the capital of Florida, but it is a proposition. So therefore, this one should also be true because this is a proposition as well.
Oh, okay. So you're just saying which one's proposition first, and then you'll do the truth value, right?
Exactly. So
Oh, okay. Sorry.
So
I was like kind of confused about that. Continue.
Sure, it's good that you asked. So here we have A to D, which are propositions, and then we have E part, which is not a proposition because the value depends on X.
Sir, just a second. Is this necessary that we know geographical knowledge for this course? Because I'm not good with capitals and everything, and if these are one of the questions, it's going to be a bit tough.
Yeah, I know, but don't worry, we won't be making any such questions in which you will have to know the geography or history questions. Okay.
Okay.
So these are the propositions, right? So now if we are to evaluate the truth values of these propositions, so Boston is the capital of Massachusetts. So I'm not really sure about that. So maybe it's true or false, but we know. So here, these two questions on the top, Boston is the capital, Miami is the capital. We don't know about this. So we won't be asking you these questions if this is the capital of something or this is not the capital, or was this person the founder of this thing or not. So we will be asking you simple questions that will be easier to understand and evaluate. Okay, so these two ones, as one of you asked, like, do we need the knowledge of these ones to solve these questions? You don't need to. But what important is that you know the concept. So did everyone understand like what a proposition is?
Yeah.
100%.
Yeah.
Okay, that's
Oh
great.
yeah.
Okay, let's take another example. Okay, so here the other example is, what is the negation of each of these proposition? So so what is basically a negation? A negation is the not of a statement. So if I say something is true, then the negation will be false. So let's do an example to give you a more understanding. So now in this question, we note that these are the propositions. Now what we have to do is we have to find the negation of these propositions. So we have Linda is younger than Sanjay. So the proposition of this statement will be Linda is not younger than Sanjay. I think the meeting is gonna stop in like 10 minutes. So if the meeting expires, so you guys can rejoin this meeting, okay? Because I think we don't have the pro access, so we need to upgrade. Okay, so Linda is not younger than Sanjay, or what we can say is it is not the case that Linda is younger than Sanjay. Okay, this is the negation of this preposition. So now we say Mai makes more money than Isabella. So we can do the same thing here. So we can say Mai does not make more money than Isabella. Or we can also say it is not the case that Mai makes more money than Isabella. So there are different ways of saying one thing. But what's important is, again, that you need to understand what the concept is. So here, for this C part, Mosh is taller than Monica. So we will say Mosh is not taller than Monica. This is the negation. And then same, Abby is not richer than Ricardo. And then we can make up, express the statement in the different ways as well. Okay, so if everyone is good with this, we can move forward.
Yeah.
Yep.
Okay. Okay, so now, so what is the negation of each of these propositions? So there's another example, just the same. Here we have to do the same thing. We have to define the negation of these propositions. So Mai has an MP3 player. So Mai does not have an MP3 player, or we can say it is not the case that my has an MP3 player. The next is there is no pollution in New Jersey. So we can say there is pollution in New Jersey because the negation of negation is actually true. So that's why. So 2 plus 1 equals to 3. So this one we can express as 2 plus 1 is not equal to sign. I'm not sure how can I do it from here. But you can just put the sign here, not equal sign. Equals to, so this will be the negation for this statement. And the summer in Maine is hot and sunny. So we can say the summer is not is in Maine is not hot and sunny. Okay, so it was just like the previous example, but a little bit more advanced. So we can move on to another example. Okay. So again, we are asked to make the negation of these propositions. So Steve has more than 100 gigabytes free disk space on his laptop. So Steve does not have more than 100 gigabytes free disk space on his laptop. And then Zach blocks email and text from Jennifer. So Zach does not block emails and text from Jennifer. Now, this 7 dot is basically just like 7 multiplied by 11 multiplied by 13. So we can either say it this way or the other way. It's completely fine. But because in the question it's done this way, so it's better to do it this way. So again, so this one, we just replace it with negation sign. Negation or the not equal. And for this one, it will be Diane does not rode her bicycle. Ride her bicycle 100 miles on Sunday. Okay, so these are some of the examples of the negations of a proposition. So let's take another example. Does anyone have a question regarding this?
The fourth one shouldn't be Diane did not rode her bicycle 100 miles on Sunday.
Yeah, well, the grammar is not really important, but we can actually do that. Okay, but what important is, so this not here, so it has to be the negation of this statement. Okay, so yeah, so again, so we won't be taking out marks for incorrect grammar or for not sufficient knowledge of history or geography. Okay, so let's take another example. Are there any other questions?
No.
Okay, let's move forward. So this one is another question. So this is a pretty big question. So I'm giving you some time to go through the question. Okay, so now let's see what the choices are here. So let me just put it on one screen. Is everyone able to see that clearly?
Yeah.
Okay. So let's do the part number A. So here we are asked that does Quicksort Media had the largest annual revenue? So we have to determine the truth value of these propositions. We know that these are the propositions, but we have to determine the truth value of these propositions. So again, in the exam, you can expect something like this. So we will have given you some paragraph, and then you will have to determine the answer based on that paragraph. Okay. So now, so this part A, so we are asked that Quicksort Media has the largest annual. Okay, everyone is back. Let's wait for a few minutes so that everyone can join. Okay. Okay, now, so the part A. So Quicksort Media had the largest annual revenue. So is this true or false? So here we know that this information is not correct. This information. So based on this information, this answer is not correct because here Acme Computer has net profit of 8 billions and an annual revenue of $138 billion, which is more than $111 billion. So therefore we say that this is false. Okay, let's do part number C. Okay, so here Acme Computer had the largest net profit, or Quicksort Media had the largest net profit. So here we have two propositions, and this is a compound propositions. So here this is one proposition before the or, and the second proposition is after the or. So here let's evaluate the first proposition. So Acme Computer has the largest net profit. So let's see if this statement is true or false. So if we read this paragraph a little more carefully, so we will see that this statement is actually false. Okay, and then we are supposed to OR this statement with this proposition. Quicksort Media had the largest net profit. So if we see here, so Quicksort Media has a net profit of $13 billion, which is more than all the other ones. So we know that this statement is true. And so we have one false and there's another true, and they are ORed. So this is very actually important. They are ORed. So when one proposition is ORed by another, so whoever has the truth value take the precedence. So here, this will evaluate to true. So false or true equals to true. Okay.
Sorry, I have a question.
Yes.
I thought that proposition are not supposed to be true or like true and false. Is that?
We
I don't
are
get that.
determining the truth value of the propositions. So proposition is something that either evaluates to true or false, right? It cannot evaluate to either true or false. It does not depend on a value. So for example, here we saw an example here. So x plus 2 equals to 11. We say, not this one. Yes. So we say x plus 2 for the part E. So we say that this is not a proposition because the value depends on the value of x, right? So therefore, this is not a proposition.
Okay.
Okay, but let's say if we know that x is, let's say 5, right? So 5 plus 2 equals to 11. We know that this is a proposition, but the value is actually false.
Oh, I see. Okay.
Okay.
Yeah.
Any other questions? Okay, if no more questions, then we should move forward. Let's take another example. Okay. So here, I'm giving you a few minutes to go through the question and then we can start.
Okay.
Yeah, hi. We are only going to do some parts of the question, right?
Yeah, because the other parts could be done likewise. So that's why I'm trying to cover like different examples.
Okay.
Yeah. So as I mentioned earlier, so there are 2 tutorials. So I will be doing some parts and the other TA will be doing the other parts. But I think the other recording as well will be uploaded. So you will kind of have all the answers. Okay, let's start. So here we have 2 propositions. Swimming at the New Jersey shore is allowed, and the other is sharks have been spotted near the shore. So they are denoted by P and Q. And we are asked to express these in English sentence. So here, let's take the A part. It is negation of Q. So this sign over here, this is the sign of negation. And so the negation of Q. So we know that Q is sharks have been spotted near the shore. So the negation of this statement will be sharks not being spotted near the shore. Okay. Okay. So now B part is P, and this sign is and Q. So P and Q. So if we take P, so P is swimming at the New Jersey shore is allowed. And this is the sign of and. So we add and sharks have been spotted near the shore. Okay, let's take a little difficult example. Let's take example number D. So it says, so this sign is here of implication. So it means that if this is true, then this will be true. So if P is true, then only negation of Q will be true. So let's say how it will be in English. So if swimming at the New Jersey shore is allowed, then, so here then is important. So if and then, so if swimming at the New Jersey shore is allowed, then sharks have not, because it's negation of Q, right? So it's not been spotted near the shore. Okay, so if, so this if, then negation of Q. Okay, let's take another one. Let's take example number G. So this sign over here, it is the sign of biconditional. So it's also read as if and only if. So P if and only if negation of Q. So we will say swimming at the New Jersey shore is allowed if and only if, or we can say also IFF. So swimming at the New Jersey shore is allowed if and only if sharks have not, because of the negation here, not being spotted near the shore. Okay, let's do a last one. It's a little more difficult. So here we have negation of P, and whenever something is in the brackets, it's always resolved first. So we will say here, swimming at the Jersey shore is allowed, or sharks have not been spotted. Right? So let's put it down here. So we take this P first. So I'm not sure here if you guys have the chance to go over the precedents for the compound statements. So here you just putting the precedence over here. So negation has the higher precedence and has the second highest, and so on. So here, if we consider this, so solving this each part based on the precedence, we will say that negation of P and P or negation of Q. So let's solve this inner part first. And let's put this negation of Q statement out first because that has the highest precedence, right? So sharks have not been spotted near the shore, or, because of the or sign here, or swimming at the New Jersey shore is allowed, right? And this is allowed, and so and here, so we will deal with this negation of P here now. So swimming at the New Jersey shore is not allowed. Okay, so dealing based on the precedence.
Can you repeat the precedence part again?
Yes, so here the negation has the highest precedence, and the and operator, it has the second highest precedence. Okay, so whichever has the highest precedence, we take that first. Okay, so here, because in the bracket, so it takes always the precedence. Okay, so we take the bracket part, and then in the bracket we see that negation of Q has the highest precedence, so we go with that. Okay, so we say negation of Q is shark have not been spotted near the shore, right?
Yeah.
And then we take this or. Okay, this or, we put this here, and then we say swimming at the New Jersey shore is allowed. And then we take the and operator because these ones are joined on and, right? And then we say swimming at the New Jersey shore is not allowed. Okay. Okay, let's move on to a different question. Okay. Okay, so likewise, we have another example. So we have two propositions and we are representing them by P and Q. And then we are asked to write these propositions using P and Q logical conjunctive. So we have the statement, let's take the first statement A. So it is below freezing and snowing. So here we have to use both of them because they include both of these proposition symbols. So it is below freezing is represented by this P, right? And so there is another and here. So we add the and sign. Okay, and sign I luckily have on keyboard. So snowing, so it is below freezing and snowing, so and Q. So if we have to read this propositional statement using those variables, so we will just replace those variables with the statements and it will be just like part A. Okay, let's do part C. It is not below freezing and it is not snowing. So we know that it is below freezing is P. So in order to represent it is not below freezing, we will just say negation. So I'm just writing out negation. You guys are supposed to replace this with the sign because I don't have it on the keyboard. So negation of P, so you know what the sign of negation is. So this sign is the negation sign. Okay. So negation of P and it is not snowing. So negation of Q. No. Q. Here.
Sorry.
Yes.
What about B? In B, there is only but. What does it mean? Or, and, there isn't any other other thing that we determine it's or, and, or.
Okay. So here, so these are basically called the connectives between the two propositions. So just like
It's definitely and, right?
Sorry?
Part B would definitely be and.
Yes, that is and actually. Yes, you're right.
Oh,
So
okay.
just like in English, we have different ways of saying one thing. So likewise in proposition, we can do the same. So here, if you go to your slides of exercise 1.1, and if you will see slide number slide number 11, so you will see all different ways of saying something. Okay, so this one, if we are supposed to do part number B, so it is below freezing, we know that this is P, but not snowing. And so it's not that they are happening at the same time, right?
Yeah,
So
got it.
it is saying it is not below freezing but not snowing, so it should be and not negation
Q.
Q.
Right.
Okay. Okay, let's do part number E. So if it is below freezing, it is also snowing. So here, when we say if or then statement, whenever we have if and then or something similar to if and then we know that this is implication. So if it is below freezing, so P, then it is also snowing. So we are implying that when it's freezing, then it is also snowing. So this is implication clearly. So P implies Q. Okay. Does anyone have any questions?
Just one question. Well, how's the but not and again?
B part?
Yeah, I just want to understand like the but not. How does that become and?
Because here we are saying that it is below freezing but not snowing. So it's like we are not saying that it's either one of them, right?
Okay.
Yeah. So therefore, when it's not either one of them, it has to be both of them. Here they are dependent on each other, right? So it is freezing, it is below freezing, but not snowing, right? So whenever there is a dependence between these propositions, right?
Okay.
So
Yeah.
there is some element of dependency, right? So
Right.
therefore we are using this and.
Oh, okay. So the dependence. All right.
Any other questions?
Hi. Can you hear me? Oh,
Yes.
okay. I want to go back to number 11, part H.
I'm sorry.
Now I want to go back on question 11, part H.
Here.
Yeah.
This one.
Yes. Are you sure that we had to write our answers in order of the presidents first?
Well, for now, it doesn't really matter because you're just converting into English, right? But when you will be solving these expressions and these equations, So it's actually gonna matter. So it's a good practice to always just like use the best practice at first, right? So if you were just to put this statement before here, it would have been okay as well. But because we have the precedence of the operators, and later on we will be studying the equations and solving these expressions. So at that time, it will be easier for you if you just do with the precedence right now.
Okay, so basically the way that you worded your answer is just to help us get ready to solve like with like questions with like precedents like not P or not Q and like dealing with the Morgan's laws.
Yes, exactly.
Oh, okay, thanks.
Okay. Any other questions? Okay, let's do a last one from this exercise if there is no more questions.
All of these questions were from 1.1, right?
Yes, this one is 1.1. So we will take a last question from 1.1. We take a small break and then we can continue 1.2.
How long is the break?
15 minutes.
Oh, okay, so exactly what time do you want us to meet? Meet again?
Yeah, so after we finish this, after 15 minutes, we can meet again.
Oh, okay.
Okay, so again, so we have these two propositions, and then we have some sentences, and we are supposed to convert those into propositional symbols. So let's do the part A. So here we are saying you do not drive over 65 miles per hour. So these two propositions are you drive over 65 miles per hour. So if I have to represent the A part in terms of propositional symbol, I will say that negation sign, and then part number P. Okay. Okay, so part number B is you drive over 65 miles per hour, but you do not get a speeding ticket. So here again, it's a but, right? So it will be like an and, okay? So you drive over 65 miles per hour is symbol P, but, so but is and you do not get a speeding ticket is negation of Q. Negation sign Q. Okay, so this is the B part. C part here. You will get a speeding ticket if you drive over 65 miles per hour. So whenever we have if and then like structure, when there is something has to be true before the other thing can happen. So this is in case of implication. So you will get a speeding ticket if you drive over 65 miles per hour. So you will get a speeding ticket. So here, if you drive over 65 miles per hour, so P, negation, implication, I mean, and then you will get a speeding ticket, Q. Okay.
This part, the statement is written the opposite way, right? The Q part is written first, then the if part is after that.
So here, which part? So we have to decide like what is the prerequisite. So this part B here, this is called the hypothesis or the assumption that has to be true before a consequences Q part can be true. So in this statement C, if you see, so it says if you drive over 65 miles per hour, right? So this is something that needs to be true before you will get a speeding ticket, right? So if you drive over 65 miles per hour, So which is the P part, right? Which represents this P. So if you drive over 65 miles per hour, then you will get a speeding ticket. Okay.
Okay, so the first statement is dependent on the second statement. That's why we're writing it
Yes.
the
So
way.
yes. So it's important, like you can draw some sort of dependency beforehand so that you can write it clearly. Okay. Let's do part number E.
Yeah.
So driving over 65 miles per hour is sufficient for getting a speeding ticket. So again, here we have a dependency again as well. So when this one is true, then we see the result, right? So when we do this thing, then we get this thing. So driving over 65 miles per hour, which is P, then is sufficient for getting a speeding ticket. So here this is a implication again, because here one statement is dependent on another. So if we do this thing, we get this thing. So P implication Q. Okay. So if you don't understand this thing, I would suggest, like on your slide number 1, go to the slide 11 of your PowerPoint slides 11. It's called chapter 1, 1.1. Okay, let's do the last one. So it says, whenever you get a speeding ticket, you are driving over 65 miles per hour. So here, if you will notice that there is also a sort of dependency, but this dependency is the other way around. So it's saying whenever you get a speeding ticket, so it's like an implication as well, but implying in the other way, so in the other direction. So here, whenever you are getting a speeding ticket, so we are assuming that we are getting a speeding ticket, and then we are making a conclusion that we are driving over 65 miles per hour. So therefore we will say Q implies P. Okay, are there any questions?
No, could you explain the G part again?
Okay, so here, so whenever we have implication, so implication is basically we make an assumption, and then we say if this assumption is true, then we reach a conclusion. So in order to get to the conclusion, this must be true, right? So here we are saying whenever you get a speeding ticket, we are assuming that whenever you get a speeding ticket. So this assumption is our statement, is our proposition Q, right? Right, if you see here, whenever you get a speeding ticket, you get a speeding ticket. Okay, so Q. Now we put the implication sign, and then we reach the conclusion that we must have been driving over 65 miles per hour, which is P.
So sorry, it's not by conditional whenever.
Whenever is actually implication.
Oh, because I thought maybe it means if and only if it's by conditional.
If and no. Let me actually. Yes. So if you will see here, there are different ways of expressing P implication Q. So P a Q whenever P is sufficient for Q is necessary for P. So these are all different ways of saying P implies Q.
Right. Yeah.
Okay, so it's not only if and then, it's whenever we have one thing dependent on another. So one thing has to be true before the other can happen.
Yeah, that's right.
Okay, so this implication. Okay, so this one actually covers our exercise 1.1 questions. So after the break, we will continue exercise 1.2, and the time right now is 6:36. So let's meet at 6:50 or 45. What do you guys say? Okay, let's do 6:45. Okay, I'll see you guys at 6:45.
Okay.
Okay, all right. See you guys. Okay, everyone's back, and let's start now. Okay, so this is these are some questions from the exercise 1.1. And if you want more exercises examples, there are some in the slides as well, and the other ones are in the other tutorial. So make sure to check them out as well, and you can absolutely try on your own, which is absolutely perfect. So now let's move forward to exercise 1.2. So exercise 1.2. Let's take first example from exercise 1.2. Can everyone see my screen?
Yes.
Yep.
Okay. So this first question from exercise 1.2. Okay, so here, so we have again two propositions. One is E, which is you can edit a protected Wikipedia entry, and the other one is A, which is you are an administrator. Now we have to make this in a proposition logic form. So this statement you cannot edit a protected Wikipedia entry unless you are an administrator. So in here, we also have a sort of dependency that we need to be an administrator before we can edit the protected Wikipedia. Okay, so again, here we will say that A, which is you are an administrator. So if you're an administrator, then you can edit the Wikipedia. So A implies E. Okay. Okay. Another example.
Hi. But the E, isn't it supposed to be negation? But you cannot edit a protected Wikipedia entry.
Yes, you're right. Actually, yeah, it should be the negation. So if you are an administrator, so it should be negation of here. So express your no, it should be actually like this, right? Because you need to be an administrator, right, in order to edit the protected Wikipedia.
What about the unless keyword?
Okay, unless here is also one of the keyword for the implication. So you will see here. So Q unless negation of P is also a way of expressing implication. Okay. So here these are the different ways of expressing implication. If we look at biconditional, so biconditional is when we say is necessary and sufficient for if, then, and, conversely, and if and only if. So here it's missing an F. Okay. So whenever we have unless, whenever, necessary, sufficient, alone, when, only if, so these are different ways of representing an implication. So these are actually very helpful ways, and I think you guys need to keep those in mind. Okay.
Yep.
Okay, let's take another example. So the example is this. Let me just maximize it. Okay, so this is a little bigger question. So just take some time reading this question. So in here, we have to define the statement: you are eligible to be president in the USA only if you're at least 35 years old or at the time of birth. So this whole statement we have to express using these propositional variables. Okay, so let's start now. So the first thing is that you are at least 35 years old. Okay, so in order to represent this, you will take A and were born in the USA. So this is and condition, and born in the USA is B. Now moving onwards, we have here or at the time. So you were born in the USA, or at the time of birth both of your parents were citizens. So in here we will put up a bracket and we will say that or, let's put up the or sign. This will replace the or sign. Or sign. So you were born in the USA, or at the time of your birth both of your parents were citizens, which is represented by the proposition P. And now the other one statement is, and you have lived at least 14 years in the country, which is the proposition R. So again, so we need the and operator here. So if you have these qualities, then what you will be able to, you will be eligible to be the President of the United States, which is represented by the proposition E.
Excuse me, I'm a bit confused. Isn't like are at least 35 years old and born in the USA supposed to be together? And then
Sorry, which one?
Hello?
Yep.
Yeah, I was wondering, like, isn't I mean, are at least 35 years old and were born in the USA supposed to be together, and then we have or and the two others statement together? Or
So here it says that here, if you are at least 35 years old, right? This is one thing that is for sure. You need to be 35 years old. There is no other way out. The other condition is that you were born in the USA. So there are some certain conditions in there. So you were born in the USA, or so here you say. So this is the and which comes. So here, this condition you need to satisfy A, you need to satisfy. And now you have to satisfy either this B in here.
Oh, okay.
Or you can satisfy this one. And then once you satisfy these conditions, then you're eligible to be the President of the USA.
Oh, okay. Okay, thank you.
Okay, other questions?
But isn't it should be the opposite way? Shouldn't the E come in front?
This is the assumption, right?
Miss,
This one
I
is
have a question. Okay.
The assumption should be E, right?
no, E is the consequences, right? So you
Yeah,
are eligible.
yeah.
Oh, okay. But if we try to reconstruct the statements, then the sentences would change the meaning, right?
Okay, let's try to do that. So A is basically we are saying that you are at least 35 years old, right? And so now we are in the bracket, and we say that B, what is B? You were born in the USA, or we use the or sign, or now you need to have P. P is at the time of at the time of your birth, both of your parents were citizens and you have lived at least 14 years in the country. So this condition P and R or B must go with the A to be eligible for being the president of the United States.
One thing, will it matter if I put the E in front, make it biconditional? Will it make it biconditional?
So like E and then you want to put a biconditional sign?
Not the biconditional sign, the same arrow and all of this in front of E.
Over here?
Yeah.
And then what else should I put here?
The whatever we wrote for A, B, or sign P and R.
So this whole, so you just want to switch the positions like this?
Yeah, yeah. Does
Like
this
this?
make a difference?
Yes, of course. Here it makes difference. Here we are saying that you are eligible to be the president of the United States. This is not a correct assumption. This is actually a consequence.
Okay,
Right?
so we're actually interchanging their roles. That is wrong.
Yes, that is wrong because here, as I mentioned earlier, that the things before the arrow must be the assumption. They are also called hypotheses or premises. So they must be satisfied before the thing after the arrow can conclude.
Okay.
Okay. So once you have satisfied these things, then you can go here. So here, as the question asks, you're eligible to be the president of the United States if you are at least. Okay.
What are the if all the conditions are given that we have to satisfy? Those are the assumptions.
Exactly.
Okay.
Miss, why did you add an AND operator between A and B? Hello?
Sorry, what's your question again?
Why did you add an AND operator between A and B?
Okay, so here we have to put the AND operator because the conditions suggest us to. So here, if we look at it carefully, it will say if you're at least 35 years old, were born in the USA, right? So were born in the USA. You have to be born in the USA. Or what you can do is you are at the time of your birth, both of your parents were the citizens and you have lived. So let's break it down. Maybe it's a little more. So let's put this condition here. So this condition P and R, right? It represents this at the time of your birth, you were citizens and you have lived at least 14 years in the country. So it's represented by P and R. Okay, and now what we are saying, this or here is or with were born in the USA. Okay, so we put the or sign here, and then we put B because it is a necessary condition for this. Okay, as per the statement. So now we have this. Now we are saying if you are at least 35 years old, this is another important condition for this. So you put the bracket here, you put A here, A, and then you put the N sign here. And then if you have satisfied all these conditions, then the conclusion will be that you can be eligible to be the president of USA.
Why did you add the brackets?
Okay, so the brackets are added because the things in the brackets, they need to be solved first. Because if I just remove the brackets, well, in this case, it won't matter much. So if I remove the brackets, right? So this is or, right? And then here. and here, right? So in here, we won't be able to know, like if we have memorized the precedence table, which let me just put on here. So here, as per the precedence table, so the brackets, they basically specify the precedence. Okay, so if you put the brackets, it signifies that this condition has to go with this condition. So this says here, and I can pick B from this bracket, or I can put this P and R from this bracket because they are or, right? So I can take B, or I can take P and R from this brackets, okay? And then I can AND it with A in order to be the President of United States. Maybe this example is a little harder for you guys. So, but there are a lot more examples. So once you will get used to them, you will really find it easy, like just interpreting these ones in propositional logic without any trouble. Okay, are there any questions?
No.
Okay, let's take another example. Okay, here's another question. Do the same thing. You have to interpret the sentence in Boolean using Boolean variables. So here we have already done one example where we have used the word whenever. So whenever is another keyword for implication. So whenever is sufficient, is necessary, implies, if, then. These are all basically representing implication. So if we take the first propositional statement, so the message is scanned for viruses. This is represented by the variable P. Whenever the message was sent from an unknown system, and this is represented by the variable Q. So now they are linked with whenever. Now here we have to understand what is the assumption and what is the conclusion. So here we say that the message was sent from an unknown system, which is our assumption. And the conclusion is the message is scanned for viruses. So when we put this together, so we say Q implies P. Okay? Assumption implies conclusion.
Okay, yeah.
Okay, makes sense?
Yeah, I see now. Yeah.
Okay. Let's do. Let's do this part as well. So it is necessary to scan the message for viruses whenever it was sent from an unknown system. So again, we have the keyword here, necessary, right? So we know that this is implication. So it is necessary to scan the message for viruses whenever it was sent from an unknown system. So whenever it was sent from an unknown system here, we examined this and we came to know that whenever it was sent from an unknown system is the assumption. So we say Q, and then we know necessary is another keyword for implication. So we say implies. It is necessary to scan the messages, which is P. Okay. So we will say whenever it was sent from an unknown system, it is necessary to scan the message for viruses. Any questions?
So you're basically like identifying the assumption and the.
Exactly, yes.
Yeah. Okay.
Okay, so what you need to do is you first identify what are the assumptions, what is my value dependent upon, and then you sort out after that is being true, then what could be the possible consequences of this assumption, and then you separate them with the arrow.
Yeah, actually makes sense now. Yeah. Okay.
Okay. Okay. Now let's take a little hard example. Let me just put it on the next page. Okay. So take a few minutes to read the question. Okay, so here we have 4 different propositional statements. So let's identify those. So let's say here. So here, system is in multi-user state. So this is one propositional statement. The second one is system is operating normally. Okay, so first let's identify all the propositional statement, and then we will associate the Boolean, the propositional variables with them. The kernel is functioning, and the fourth one will be system is in interrupt mode. So here we have 4 different Boolean, propositional statements. So let's associate some Boolean propositional variable with them so that we can just write them in a shorthand. So let's associate variable P with this, Q with this. You can associate anything with this, like A, B, C, but because P, Q, R, S, these variables are like used from like a long time, so they are generally considered the best practice. Okay, so here PQRS are representing these 4 different propositional statements as identified in this paragraph. Now, what is asked here? We are supposed to answer, are these system specification consistent? So a system specification is consistent if they all becomes true under some value. So again, the definition is in the chapter, the lecture slide number 2, last slide number 5. It says a list of propositions is consistent if it is possible to assign truth value to the proposition variable so that each proposition is true. Okay, let me just put this here. The definition for you. Okay, so now that we have identified all the propositions, and then these are proposition variables alongside. Okay, now let's put them in way of dependency. So the first statement is the system is in a multi-user state if and only if it is operating normally. So we will say that P bidirectional, and Q. Okay, so this is our first propositional statement represented using propositional variables. Okay, the system is in multi-user state if and only if the system, if it is operating normally. So this is representing this one. The other one is Q implies R. Next one will be negation R or sign S. And fourth one will be negation P implies S. Fifth one is just the S itself, because it says that the system is not in interrupt mode, which is
Well, that would be a negation though, right? Because it's not.
yes, the system is in not in interrupt mode, right? So now we have to identify, like, is there any contradiction in these? Is it possible that we have one value for which all of them evaluated true? We know that, so this one is the least dependent because it only has one propositional variable. So negation of S, so if we take S to be true, let's assume S is true, S is, sorry, false, then this will become true, right? Because negation of false is true.
Yeah.
Right? Now, in order to make P implication S true, what we can do is, let me here write it down. So we want P, we have to decide what could be P so that it evaluates to true. It has to evaluate to true. And then this is the implication sign. We know that we have assumed S is false. Right here. We know that S is false and it should evaluate to true. Okay, and we are not really sure what could be P, either true or false. So let's see on the this a truth table on your slide number 1. Okay, here. So for implication here, in order to make this true, and where Q is also true, right? So P can either be true or false. So we know that P does not, the value of P does not matter. Okay, so P can either be true or false. Now, doing the same way, we have to make this true, because if we don't make it true, then it's not consistent. So we must make it true. Okay, and then we also know that S is false, right? And then we have to OR it. So
We can't
regardless,
see the screen actually. It's on the
sorry.
presentation.
Sorry, guys. Okay, so here we have this statement over here. So we have to make this true, right? We know that S is false. So here it doesn't matter R is true or false. It doesn't really matter. Okay. So it does not depend on value of R, does not depend on value of P in order to be consistent. Now again, we have Q true or false. And there is the sign of implication with R. R is, we know that R, we have to, let me here share the screen. Okay. Here are. So we have to make this true. So in order to make this true, we have these 3 possibilities. Number 1 row, 2 row, and 3 row. Okay, because we cannot make it false. We have to make sure that this is consistent. We have to find one value where it values to true. Okay, so in order to find that one value, so P and Q can either be true so that the implication is true. P or Q can either be false or true so that the implication is true, or they can both be false so that implication is true. Okay, so now here Q can either be true or false. R, so let me just say we have to make it equal to true. So R can either be true or false. Okay, so in order to make it this true, right? So when both of them are true, then it's true. When P is false or T is okay. Sorry about that, guys. We're back. Okay. Okay. So here we were saying that this is the sign of implication, and then we have to make this true, this statement true. Now, in order to make this statement true, there are some truth values we can assign them. So Q and R, we have to decide on the truth values. We have to decide on the truth values. So here, when P and Q both are true, then the result is true. When either P or Q are false, then the result is true. Or when P is false or T is true, then the result is true. So we have to basically make this true somehow. The next one is, the last one is P bidirectional Q. So if we look here for the bidirectional here, so here they are true under some conditions, that either P or Q both are true or both are false. Okay, so let's make either P is true / false, P and Q are both true or are both false. Only then the result will be true. Okay, so now we will just continue with one of the assumptions here. So here we say P and Q are both true or are both false. So let's say that S is false, P is Q is true, right? So if we make Q true, then P must be true as well, so that it can be, this first statement can be true, okay? Because in here we are assuming this is true and this is true. So there's only one case where this happens, right? So P must be true as well. So PQ is true, P is true. Then this becomes true. Okay. Now if we say Q, we have already assumed it's true, implies R. Well, what could be the value of R for which it will result to true? So this is our Q and R implication to true. So this is our Q, R, and the result should be true. True, we know that P is, we know that our Q is true, right? Our Q is true. Then this statement over here, Q has to be true as well. So this in our case was R. Okay. Okay. So now here we said R is true, right? So we take R true or false. So true or false is actually true. So therefore it's true. Now P we assume is true. P true, false. True implies false equals to true as well. And the negation of S is equals to true as well. So under these assumptions, only then we will say that the system specification is consistent. I know that this is confusing and you guys have a lot of questions. So you can start asking questions.
Doesn't that make the fourth statement negative?
Yeah, so let's just remove this over here. Oops. Okay, so basically, what you guys understand is we are trying to find a value, right? So the values of the variables under which all of these implications and operators actually simplifies to true. Okay, so this is what we are trying to find. Okay, so and I am saying that under this assumption, these all of them will be true. Only then we call that such a system is consistent. Okay, so your question was this one will be false.
Yeah, this one will turn false if the conditions that you have written below, let's assume, are all there.
Okay, so P is true, so negation will make it false. False implies, so here if we see the truth table, so false implies false and then Q is true. Have we considered? Yeah, so we have said Q is true, right? Here. So when it's false implies true, the result is true, right? So here, so false, true. So our P is true, but with the negation it becomes false, right?
Okay.
And then S is here false. Okay.
Miss, we assumed that S was false without the negation.
Sorry?
Right.
Yes.
We assumed that S was false without negation.
Yes, we assume
Right.
S is false without negation. So with the negation, this statement will become negation of false is
True.
yes.
But for me,
This becomes
for the
true.
number 3, but isn't number 3 supposed to be false since it's false or false?
I'm sorry.
Since S, isn't number 3 supposed to be false?
Number 3, okay. So let's see. So negation of
Yeah.
R
Yeah.
will be false. Okay. False or false. Okay, yes, you're right. Okay. Yeah. So it has to be false. So it will be false. So we cannot find such a statement under which all of this will evaluate to true. So therefore, we will say that such a system is not consistent because we cannot find the values for these variables under which they will result all of them to be true.
According to, like, if they have to be consistent, all of them should be either false or true, right? They cannot have one false, like the assumption that we have taken.
Yes.
So they all have to be either true or all are false, then our conditions are met.
So here it says that in the definition, so it says that truth values to the proposition variables so that each proposition is true. So each must be true, right? So this must, if this would have evaluated to true and all of them have evaluated to true, then we say that we have found some values of these variables under which they all evaluate to true, and hence our system is consistent.
Okay. In the way you have written.
Questions?
Hello.
Yes.
Yeah, I said like the way you have written F or F is equal to true and F implies. Do we have to show all this, or do we straight up have to write the statement up to 5?
Well, I actually have done the. Yeah, I have done the rough work behind the logic so that you guys can understand. But if you guys know, like, okay, this is like clear that this is a value under which all of them evaluated true, you probably don't have to show. But if the question requires that show you're working, then you definitely have to show, because this will make you understand better, because you cannot just right away get the answer unless you have practiced a lot.
Okay.
Okay. So this is basically how you find a system is consistent or not. So you will assume some values for these variables, and then you will check with those values that either these propositions evaluate to true or false. If they all evaluate to true based on the assumption, then we say that the system is consistent, because we know that there is some value for those proposition variables under which all of the propositions evaluate to true.
Okay.
Okay, we will hopefully do more examples in the coming days, and this will clear up your doubts as well.
Will you be uploading this document with the recordings, or will this only be included in the recordings?
This is also in the recording as well, but I believe like I will have to talk to the professor, like what he says, and then.
Okay.
Okay, so this is it for today. The time is until 7:30, so actually we have surpassed some few minutes. So, but now you have learned a couple of things, so try to work on these things on your own as well. And if you have questions, just note them down for the next tutorial on Thursday, 5:30 p.m. Okay, so see you guys next week.
Sure.
Thank you so much.
Okay.
All right,
Thank you, man.
Yeah.
Bye.
Thank you very much.
Bye.
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 Bye.